Okay, so now we're going to get into a discussion of the atom. So, the atom, as I think I said in the last video, is the smallest fundamental particle of an element that can exist. And it is also the smallest unit of an element that can actually participate in a chemical reaction. Now, the first person to come up with a very comprehensive model of the atom is an English school teacher by the name of Dalton. In fact, he did this 2,000 years after Aristotle, who was the first person who came up with this notion of the smallest unit of a substance being one small particle. And I think the term that he used, which is a Greek word, if I'm not mistaken, called atomos, from which we get the word atom. So he came up, meaning Dalton, came up with a model which arose out of experimentation. So the next slide basically goes into what the atomic theory is about. So the first line says that elements are composed of minute indivisible particles called atoms. All right. Now, let me just stick a pin here and say that later on, as you're going to see a few slides down, this particular aspect of Dalton's atomic theory has been proven not to be so. It turns out that atoms are divisible and can be broken down into smaller fragments, into even more fundamental fragments. All right, so we're going to discuss that later on. But this is how science works, right? Somebody comes up with a theory, and the theory holds until somebody does an experiment or experiments in order to test that theory. And in this case, this particular aspect of Dalton's atomic theory was tested and found to not be true, right? That you can actually break down an atom into smaller fundamental units. Anyway, on to number 2. Atoms of the same element are alike in mass and size. Number 3, atoms of different elements have different masses and sizes. Number 4, chemical compounds are formed by the union of 2 or more atoms of different elements. Number 5, atoms combine to form compounds in simple numerical ratios such as 1 to 1, 2 to 2, 2 to 3, and so on. And number 6, atoms of 2 elements may combine in different ratios to form more than one compound. All right, so that's basically what Dalton's atomic theory is saying. So just to re-emphasize, one aspect of Dalton's atomic theory says that atoms of each element are alike in mass and size. So if you could actually see the atoms, you'll see that, for example, you would not be able to distinguish between any 2 oxygen atoms because they'll look exactly the same, and the same would be true for the hydrogen atoms. You would not be able to distinguish between any 2 hydrogen atoms because they look exactly the same. All right. Another aspect of Dalton's theory is that atoms of different elements are not alike in mass and size. So if you were to compare a hydrogen to an oxygen atom, they will look different if you could see them. All right. Another aspect of Dalton's atomic theory is that atoms combine in specific ratios to form compounds. So that is seen in the case of water, where the ratio of hydrogen to oxygen atoms is 2 to 1, or in the case of hydrogen peroxide, where the ratio of hydrogen to oxygen is 1 to 1, or 2 to 2. All right. Okay, so we're going to stop here for now, and then we'll look at a discussion of composition of compounds. Until next time.